I've personally worked on 5 spin-off companies from the university over the last 10 years. The last 2 being the most recent, Tissue Regeneration Systems, also known as TRS, and Inset Biosystems. Inset Biosystems is a University of Michigan spin-out, and our target market is the IVF market, the in vitro fertilization market. They were the first company last year to culture human embryos on a microfluidic chip. The improvements that we've seen in animal data and animal research performed at the University of Michigan dramatically improves the growth rate and the health of these embryos, which will translate into dramatically improved success rates when going into humans.
Here at the university, we spend probably a little bit north of $850 million on a variety of very high-quality research. The discoveries that come from that research come to our office to be evaluated, and it's the stated goal of the university to try to have the benefits of these discoveries reach the general public. So that is our role. We receive about 300 of these discovery ideas each year, and we have a full staff of specialists who help us evaluate, working with the inventors and with outside partners to understand the potential of each one of these discoveries. Technology
transfer is a process. It's not, you don't walk in, buy it, pull it off the shelf and pay for it. Typically, I spend 2, 3, 4, 5 months meeting with people, looking into technologies, going to the labs of the inventors, and learning about the technology, but also really learning about the people behind it. A key part of that process is working with the business formation unit at the tech transfer office, and they kind of sit in between the professors and the research and the college and the outside world, which would be me, the venture capital funding source.
We handled the invention disclosures, the discoveries from the university, and they're varied. Sometimes they're sufficient to form a company, that they are what we call platform technologies that someone would be interested in, has the capability of growing into a full-blown business.
Because we invest so early, we don't have to see it all done, because that can take years, but we want to see the initial foundation of the company can be commercialized as practical, and we see some of it working in the lab.
So we use people like Jim to help us make that assessment, to understand what's the best use of technology, and for those that are selected to be potential startups, we use resources like Jim to help us develop the technology to reach a stage where it can receive funding.
Most of the investments I've done have been where you have a professor who's a medical doctor, a clinician, so he's practicing in his field, and he or she has a need. They see a way to improve the procedure, be it eye surgery, be it in vitro fertilization, or perhaps spinal surgery.
There's a lot of what we call interdisciplinary interactions, so we may find that a technology that may have been derived within the College of Engineering might have some applications in dentistry or in a medical clinical environment.
So it's this kind of interdisciplinary research that I find is really important to achieve success for these startups.
And Ann Arbor itself, despite being in the Midwest, is quite fortunate with the amount of resources that are co-located within the region. And these resources, which is talent and infrastructure resources, are quite valuable in helping us develop these technologies to their fullest.
Obviously, the technology has to be world class. We're not looking to launch the best companies in Michigan. We're looking to launch the best companies in the world based on Michigan technology.
It's not always apparent in the beginning. It's definitely not a science in terms of how to commercialize. There's a lot of investment and hard work and personal interactions that are required to make this process work, but it's very satisfying.